what works best there.
Good to go.
Perfect. Thank you so much. Welcome everyone to the Wallet Interoperability Special Interest Group for March 3rd, 2025. Today on the agenda, we will hear about Did WebVH from Stephen Curran. So thank you so much. Really looking forward to digging into this topic. We are recording this call. It will be posted on the meeting page later today. We are following the Linux Foundation antitrust policy and the Open Wallet Foundation Code of Conduct. Let's see. Just want to call it the time change again. Of course, those of you who are already here know this, but the new schedule is to no longer alternate. Same time, Mondays at 8 a.m. Pacific time, 5 p.m. Central Europe, effective today. And let's see, next call on Monday, we will hear from Giuseppe DeMarco, who's a spec author of the OpenID Federation, who will present on the OpenID Federation. So really looking forward to that. Let's see, Sean, I know you had some announcements you wanted to call out before we jump in.
Just to notify folks, this session is being recorded. It may end up on YouTube. We have switched over to LFX, which does not give us the automagical ability to push a video directly to YouTube right after the meeting ends. So I got to do it manually. And we were spending a little bit more time promoting this SIG meeting. So you might end up seeing this mentioned on LinkedIn. We've posted the last couple of meetings to LinkedIn and to the OWF blog, just to let folks know, they may not know this meeting exists. We're talking about really important stuff and we want to get out there, but I also want to be really forward with everybody joining the call that this may end up on YouTube, and where I'm joining these meetings, I can tell folks that I am. Everything we do is in public, but I don't want anyone to be surprised that this is on YouTube.
Absolutely. Thank you for calling that out. Let's see. Any other announcements from anybody before we jump into our agenda? All right. Let's see. Let's go through some quick project updates. Stephen, did you want to share a bit about Akapai?
I have been around for a week. Things continue to go. I know there was, as always, about 5 or 6 PRs merged over the last week. We have not moved forward on a release. I know we're getting closer on removing from the core the AIP 1.0 issue credential and present proof protocols and moving them into plugins. We have PRs for both the removal and the plugin. So that's close. That will then lead to a new release of Akapai once that happens. So I think that's the main thing. There's been work done on logging as well. There's been a proposal put forward to restructure how logging is done and really strengthen it. And so updates are happening there.
Great, thank you.
Oh, one other dimension, it's totally relevant to this session, is did WebVH work being put in there. I've got a demo that I'm going to show that shows using Akapai to run through a full non-creds verifiable credential exchange, issue, present, revoke, and verify that the revoked credential does not verify. So full support is now in a plugin for Did WebVH, and that work, which reminded me, was that same work is happening in Credo and then subsequently to Bifold.
Okay, the Did WebVH support?
Yeah.
Okay.
That's in progress. There's a bunch of, I mean, as always, there's a pile of other things going on in Credo, but that is also happening.
Awesome. That's great to hear.
And then one other that I can report on, which is a bunch of new features in new PRs in Akrita, OWL Akrita, that came about in supporting AIP2 in Akapai, and also doing this anon-creds v2 or anon-creds with did WebVH. Patrick, who was on last week, did a pile of work using Akrita to test out and load test did WebVH implementation and did WebVH server. So that got done as well in the last week and a half.
That's great to hear. Awesome. Are there any other project updates anybody wants to bring up?
I'm sure this got brought up last week, but just to make sure, VCX did get accepted into the Open Wallet Foundation, and so their trends, they're doing a pile of cleanup work right now, and then we'll be doing the transition to move the repository from LFDT to Open Wallet Foundation.
Awesome. Cool. Great. All right. With that, I think I will kick it over to you, Stephen, for the presentation.
Okay, you can see my screen.
Yes.
And there'll be a recorded demo through this, so hopefully I can pull that off and get that to work. Getting to 1.0, did WebVH. We're really focused right now on finalizing did WebVH and specification into 1. So I'll do an introduction, a bit of a coverage of cost benefits and why we're doing did WebVH, talk about features, getting to 1.0, what is going to change. And it looks like there's only one significant change that's a very interesting one that's going to go in, and then talk about the did WebVH anon-creds method, and in doing that, do a demo. So I think people here know about this. What makes dids great? Did controller controls the creation and updating and publication of their own identifier. Updating is very important in this context, and it's the reason why dids are so valuable. They not only can create their own identifier, but they can update it as they go, and that's different from some other capabilities as we go. So they can retain a history and give access to previously used public keys, for example, for long-lasting uses such as verifiable credentials that last many years and things like that. Given a did, such as found in a verifiable credential, anyone can resolve that did, get the did doc, and the did doc holds public keys, holds services, and more. And the did controller can update the public keys without changing the did, and that's crucially important. Arbitrary types of keys can be published in a did doc, so there's great flexibility. You can have many keys in a did doc, enabling single purpose use keys. You don't have to have just one, so there's lots of flexibility. Dids can be published in many types of places, and so far we've got 200 plus did methods, many of them involving blockchains and ledgers, but a variety of other places where did docs can be posted. The joy of it is once you retrieve a did doc, it's the same regardless of the source, and that's the point of the standard, is that regardless of where a did controller has chosen to publish their did, once you resolve the did, get back the did doc, they're all the same, and you can treat it going forward. Some did methods, particularly ledger-based, allow access to the full history of the did, which means all the keys that have been used in the past, have been used to sign things, for example, and so on. And that's an important feature. Ledger-based dids have some pros and cons. I've realized now how people that are sort of outside of the did community consider ledger-based as an inherent feature of DIDs, and and obviously in what I'm talking about, they're not. We're publishing it on a web, not on a ledger, but ledgers are really good for the reasons. Some of the reasons listed here: immutability. Once a version of a DID is written, it can't be changed without the consensus of the ledger that you published it on. Ledgers can store the chain of immutable versions of a DID. Whenever a DID controller updates their DID, they're really writing a new transaction to the ledger. The old transaction is still sitting there, and so it's not affected by the fact that you have a new version written. They're replicated across network nodes, so more robust. And the creation and the updates are all signed, attested by the nodes of the ledger achieving consensus. So there's a consensus achieved before that is published. You don't have to contact the issuer to get the DID doc, so there's not a call home for when you go to use it, which can be important, especially in verifiable credential cases. And they can be very long lasting, as long as the ledger lives independent of the lifetime of the controller. That's good, except that sometimes ledgers can disappear. I'm involved in the Sovereign Foundation, and the Sovereign Foundation has announced it's going to be transitioning the ledger likely to be read-only in a very short time. And so ledgers may not last as long as DID controllers in some cases. You may get governance enabled on a ledger. So an indie ledger, for example, has governance rules built in: who's allowed to implement, through cryptography, who's allowed to write a DID to the ledger, who's allowed to endorse the writing of it, enable the writing of it, and so on. So those rules can be implemented and can limit who writes to it, and then allowing everyone to read from it. But ledgers are really hard to run. I originally wrote only one bullet to this point. Ones that don't have cryptocurrencies are hard to run, but ones that do have cryptocurrencies are also hard to run. So yeah, they're hard to run. Okay, that has led to DID web being a very popular DID method. And so it's out there and being used. It's easy to publish a DID. You just put a file on a file server. You put the DID doc on a certain place in a file server, and the DID is named based on that location. It can be directly linked to the domain, but don't rely on visual inspection. Don't rely and trust in a DID just because of where you found it. Use other techniques for that, and we include that warning in the specification of DID WebVH. It doesn't change. DID WebVH makes the verifiability of the DID possible regardless of where you get the DID log from in this case. But it doesn't change that. That just means it verifies, doesn't mean you can necessarily trust it. And you really should be using other techniques such as verifiable credentials about the DID before you trust it. With DID web, there's no versioning. When you rotate the DID, when you update the DID and write an update, the old DID doc is gone. Anything using the old keys that are not published in the new one becomes unusable. So verifiable credentials signed with an old key that are not in the new DID doc become unusable. When a DID is updated, when the DID doc is updated, there's no proof that the DID controller actually made that change. Did somebody else update the DID doc and do that through malicious means? You just don't know that. The web location and hence the DID could disappear via mergers, lost domains, etc. And it may require a call home to get the DID. If the issuer's DID is published on the issuer's website, then anyone who's getting that DID doc is contacting the issuer, and that may or may not compromise information, may expose additional information, and so that has to be considered and looked around. DIDs can be put anywhere. A did web could be published on a platform, could be published on GitHub, and so on. So that call home is not necessarily there. It's a possibility. So what is holding back DID usage? I mean, I think a couple of weeks ago we had a session where we talked about the controversy on the SD-JOT spec and it's whether to include or not include a reference to DIDs in that spec, because DIDs on ledgers are hard, like we talked about. DID web DIDs are okay, but they lack a number of capabilities. There's so many DID methods, there's 200, which one should we use? While there's an effort right now to standardize DID methods, none are recognized by standards organizations at this moment. And so we're working towards that, and we want that to happen. And the last and biggest one is perhaps X509 certificates kind of work. They're not intended for use other than in browsers and websites, but there's a key associated with an X509 certificate. And so if there's a key, why don't I just use it for other purposes than they were intended? Again, X509 certificates have no history, although there is some proof when an X509 certificate is replaced, as it is on a regular basis. But there's no history in that. The key that's associated with it, there's no history of what was in that certificate prior to its current incarnation. So again, not as good as DIDs does not, or DIDs can be. And so not really a replacement, but they kind of work, so people use them. So that brings us to DID WebVH. DID Web plus verifiable history. The name has a history to it in itself. It was originally DID TDW, Trust DID Web, but we ran into a problem with that name, so DID WebVH became the new name, DID Web plus verifiable history. There is a specification with multiple versions. There is a repository, and at HTTPS didwebvh.info is links to all the resources related to it, information about the DID, the history, implementation guides, and then links to the specification itself. Okay, so this is what a DID WebVH looks like. It looks, the second part of that, what it resolves to, looks almost the same as what a DID Web looks like. And so let's focus on the differences. Obviously, DID Web becomes DID WebVH. So that's an obvious one. This big thing here is 44 characters of a self-certifying identifier. So this is a unique identifier generated from the hash of the initial log entry of the DID. And so this is verifiably tied to the DID log itself. And so it's the beginning of the verifiability of that history. So obviously that never changes as the DID gets updated. The DID itself doesn't change as the DID doc gets updated. And as I say, so if you drop the VH and you drop this SCID segment, you would have DID web aviary.id, which resolves to almost the same thing as what you're seeing here. The difference here is this L on the end. So DID web resolves to just did.json. DID WebVH resolves to did.jsonl, which means JSON lines, which means it's not just a JSON object, but it's a JSON lines object, and I'll show you what that looks like in a moment. So DID Web is DID Web, DID WebVH is DID Web plus verifiable history. So the verifiable history, each version is an entry in a log, as can be seen down here, these green lines. Each one represents a version of the DID. It includes the did doc. The fully represented did doc is in each log entry. And the data to verify the version is also there. So the resolver retrieves and processes the entire log, hence the JSON-L file, and it verifies each version of the log, verifies the SCID that I mentioned first, and then it verifies each version of the log. Parameters configure the did and potentially are updated with each version of the did to resolve it. And that enables long-lasting dids. So for example, the parameters contain what version of did WebVH is being used. And so you could start with version, say, v04 that existed a couple of months ago. And then in the parameters section, okay, from now on, I'm going to use did WebVH version v05. And that implies certain things, what hash algorithms can be used, which proof formats can be used and things. So the specification includes in its definition in the parameters what version of the spec and what that implies. As I mentioned, the data in the data format is JSON lines, which is often used for streaming data. So each log entry is a line. So to add, we don't have a trailing, it's not a JSON object, so we don't have open and closing braces at the beginning and end of the file. And as a result, all we've got to do to extend the file is simply add another line. And by another line, I mean that the JSON is serialized to remove all white space, and then a carriage return is put in, and the next log entry is put in. So that's JSON lines. It's used in Amazon, Shopify, all of those use it very commonly. Sam, who's here, pointed out to us after we came up with the format we wanted that this is actually a thing called JSON lines, hence why we reference it. So self-certifying identifier verifies the creation of the did. So this SCID, 44 character string, is defined as a multi-hash of the first entry, calculated in a very specific way, so that when you find a reference to a did WebVH in some other object, like a verifiable credential, or in some other thing, you get just the did. When you go to resolve it, you get the JSON-L file. You can verify that first entry and that the SCID that you received from the verifiable credential matches the data in the first entry. And so that gives you that verification that that first entry is valid. There's a list of keys in the parameters that are authorized to update the did. Those keys are independent of what is in the did doc. So you do not have to use, and we encourage in the spec not to use the same keys to authorize updating the did with the keys that you put into the did doc for whatever purpose your did doc exists. So notably, to update the did, you have to have a proof from one of the authorized keys listed in the parameters to be able to rotate the did. You can have pre-rotation keys where in one version of the did you commit by putting the hash of the next public key you're using, but you don't actually put the key in. And then when you update and say, here's my new set of authorized keys, you can verify that the hashes of those exist in the pre-rotation keys from the previous entry. So that is a protection against loss of control in case your public key or your private key gets compromised. Can also be used in a post-quantum transition. So you can update a did. If you're in a post-quantum scenario where your authorized keys that are visible, your public keys are visible, that might compromise them in a post-quantum attack, the hash of the next keys cannot be, and so you are protected in that way. Versions are chained together, so you can't add a version in a ledger-like fashion. You can't add it in together. So the version ID contains a hash of the current version, including in the first one the SCID of the DID, and the version ID of the second one contains a hash of that version, except with the hash of version 1 of the version 1 log, and so on. And that means that the hash, the version ID that contains a hash, is tied together in a chain, much like you would have in a ledger. So this is the micro ledger concept. And then finally, we'll talk about this a bit. You can have witnesses that sign a version update, so that you have to get a threshold of witnesses that are willing to sign that version 2 is a valid transition from version 1. And then we're adding watchers, and that's likely the big change that will happen between version 0.5 and 1.0 of the specification. Did WebVH is can be published, and we talk about it in the spec how you publish a did web, publishing both the did.json and did.jsonl files. So the did web did.json and the WebVH JSON-L files together with a mutual, also known as entries in the did doc pointing at one another. There is a spec that was produced by a group in Canada and the US known as High Assurance DIDs with DNS. That can work. That works is tightly bound to did web, but can be applied to any did method. So that mechanism, since it works with any did method, can be used for this. And that basically says, take a key that's in your DNS record and verify the a proof in your did doc. And that binds together the DNS entry that you have to control with the did doc that you also have to control. I had more on this one that I was going to include on a potential roadmap. This was discussed long back. We haven't talked about it in a while, but did WebVH might become did web. And we're always interested in people's thoughts on that and what they might say. Okay. So this is what a log entry looks like. As I say, it's a JSON with a carriage return at the end of it. So you've got it's an object. So it's got curly braces at the beginning and end. You've got a version ID. I mentioned that the version ID contains a hash. And that hash is tied to either the SCID, if it's the first entry, which in this case it is, or it's tied to the version ID of the previous one, which contains a hash of the previous entry. So that's the combination. So you've got this 1, which is the increment 1, 2, 3, 4, 5, plus a dash, plus this hash. Version time is as declared by the did controller. They can put whatever time they want, but it must be incrementing. It must be before now when it resolved, and it must be incrementing. It must be higher within each one. But other than that, it's defined by the did controller. Here's the example of those parameters that I talked about. So, yeah.
Is there like a lock to UTC here, or is that still just up to the controller?
Just up to the controller on version time. Sorry, what did you mean?
Like, do we specify the Z indicates that it's a UTC
time
yes.
zone? Sorry, yes, it is.
Okay, it is so specified. it's always in UTC.
It always is in UTC. Yes.
Cool.
Yes. Okay, parameters. So here's an example. This one is using the method of did WebVH 0.5. So it's using the 0.5 version of the specification. And as I say, that implies what hash algorithms you are allowed to use and what data integrity crypto suites you're allowed to use. the SCID is put into the first record. So it must exist in the first record. So it is included there. And that makes it easy to find and verify as a first cut that it matches whatever you received when you resolved this. And then finally, here's the update keys. So this is a multi-key. So it's defined as to what key type this is. That is used in signing in the data integrity proof. And then the next key hash this is a multi-hash of what the DID controller has committed to use the next time for the next update, the next rotation of this update key. When pre-rotation is used, you have to change the update keys on every version. So this key will be used for this one and the next one because this is the very first one. But thereafter, in the next one, whatever this hash has to be the public key, has to have an update key in it, and there'll be a new hash for the next key. State, the state object is the DID doc. So this red is the full DID doc of this one. This is the most trivial DID doc you can get to. Notice that it contains the ID, and that in turn contains the SCID of the identifier. So that's the minimum required DID that you can see right there. And then finally, attached to all of this at the end of processing is the proof itself. So this proof applies across all of the other data values. And so, which is just the way a data integrity proof works. Again, the crypto suite ED DSA JCS 2022 is defined by the DID method. So that's in fact in DID WebVH spec 05. That is the only permitted crypto suite that can be used for the data integrity proof. So that's what a log entry looks like. And as I say, as soon as you change the data, the DID doc, you want to change it, then you just do another entry that looks almost the same as this. It's going to have a 2. Obviously, it's going to have a different entry hash, different time. The parameters may be, well, in this case, we're using pre-rotation, so update keys and next key hashes is required in the next one. But these two, the method and the SCID, would be unlikely to be in the next version unless you're going to change what version of dead WebVH you're using. Those wouldn't exist in the next one. This is a list of the dependencies. We really tried to keep it minimum. So we've got JSON lines that we mentioned, base 58, multi-hash, but only SHA-256 is permitted. The multi-hash is important because that will allow in the future to use different hash methods, different hashing algorithms. But in the V1 spec, there only is SHA-256, or at least the V05 spec, there's only SHA-256. There's multi-key to encode the public key, but only EDDSA is permitted in the V05 spec. We're using JSON canonicalization for when we're doing hashing, and we need to hash JSON. We have to canonicalize it first, so that's used. And then finally, the data integrity suite, crypto suite, JCS EDDSA is used with DID key. So very small dependencies, keeping those as minimal as we can. Okay, so once you have a DID, often you have resources associated with it. And one of the things we're doing is including non-creds resources. So that's our first kind of use case. So with DID WebVH, we implicitly, so you don't have to put this in the DID doc, is a service called Files that uses the DID core standard relative URL to say that, hey, when you resolve a when you have a did URL with a path in it, such as this, it will automatically go to the same web server location and use the HTTP URL to find whatever the object is. So that's implicit. If you want to explicitly change that so that you put resources in some other place, you can totally do that, and that's allowed. But if you don't do that, there's an implicit resolution of these objects to the same place. So for example, this status list VC resolves to a status list 2021 revocation verifiable credential. So the standard of using that status list. So that's how files get used. Portability, one of the things we worried about and got some controversy on, got some pushback on, but one of the things we worry about is that for many reasons, HTTP URLs don't last. Obviously, they can last as long as they continue to be published in that place. But if a company publishes to a certain place and then later merges with another company, or they lose their web domain or whatever, then their access to that web server could go away. So we did define a way that a DID can be changed. The DID itself is changed. So the value of the DID is no longer example.com, but rather did WebVH skid new.home.com. So it is not the same DID. However, the skid is the same, and the verifiable history, all of the log entries must be there from the beginning, from where that skid was created. So you are able to express that, hey, this it started over here, but it moved over to there at some point in its history, and you can go through the log and verify that transition. Ideally, but not necessarily, because it depends why it moved. Ideally, you would leave a redirection here so that if somebody resolved the JSON-L file at the HTTP location, it would find this one. But we can't guarantee that. That depends on whatever happened. We see this as an interesting possibility for hosting a platform hosting using DIDs for key management around services. So for example, you could have your messaging and your email and your files at Google using a DID associated with you, and then later move that to some other service, and the skid remains the same and the log entries remain the same, and Google would probably run a redirector for you that would allow all of the verifiability of your move to be recognized. So totally optional. How you use this is up to you, but these are some of the use cases that we see. Portability is by default off, and you may not, unless you explicitly turn on portability in the very first entry, you do not have portability. So it's by default off, and if you ever turn it off at any point, it can't be turned back on. So that would lock it in to the one specific location. But if you do want to have it in that ability to do that, if your use case calls for it, you can say, I want this DID to be portable, and it may move while retaining its history. Then finally, we've had witnesses for some time, right from the beginning of the definition. We're talking about, and it's not in the spec yet, of adding watchers. The important part of these features is the specification contains a simple, what we consider a simple definition of the features. So the mechanics of how you define who the witnesses are, the mechanics for what those witnesses must produce in order for a transition from one version of the DID to the next. All of those are very simple to understand and to follow. But we left the hard work to the specific deployments. So the governance of how witnesses work and who the witnesses are, the protocols around how a witness gets notified, hey, here's a new update. Those are outside of the specification. So that's left, as I say, outside. And so we don't either limit or constrain how the governance works. We leave it to whoever, whatever ecosystem decides, hey, we're going to use a bunch of DIDs and we're going to use a bunch of witnesses, and here's how it works. I will talk about watchers a little bit because that's not in the spec yet. I'm expected to work on a PR to add that. We've got a rough idea of how it's going to look. And so I'll talk a bit about that later. But witnesses basically are in the parameters. You have a witness parameter, and it's got a list of DID keys. And those are the witnesses, and there must be a threshold number of witness proofs before an update can be published. So they've got to witness the update to enable an update to be published. So the DID controller, it doesn't do it independently. They rely on the witnesses receiving the DID, the update, providing a proof to say, yep, that's a valid update, and then, only then can that update be published. Why a witness would approve it, other than verifying that it's accurate, but why they approve it or how they approve it, or sorry, why they approve it is governance, and that's left outside the scope of the specification. Yeah, so in the real world, an issuer verifier creates a DID WebVH DID doc using something like Akapai or Traction or Credo, any sort of controller. The DID doc can contain anything. There is no requirements other than to be a valid DID doc with an ID in it that matches the ID of the DID WebVH DID. That is the only requirement in the DID doc. It's got to be a valid DID doc. Other than that, it can be whatever the DID controller wants it to be. They follow the rules of their DID web server to publish the DID. So again, this gets into governance, witnessing, watchers, and so on. What rule does their DID WebVH server? And this is a link because there is an existing DID WebVH server that's been implemented and can be deployed. And it has, allows you to configure it with certain rules. DID controller creates the DID doc, follows the rules of the DID WebVH servers, puts in the parameters, and that enables the publication of the DID at the correct HTTP URL. They can then publish other resources. So we're using that in BC Gov to do an on-creds objects. We're likely to do OCA files, overlay capture architecture files for displaying credentials, whatever resources you want associated with it. They use the authorization key to, they use the keys published in their DID doc to sign and decrypt data. So again, the DID doc can contain any keys they want, and others resolve the DID doc to access the public keys and verify and encrypt data. The DID controller then creates an updated DID doc, publishing that and adding that new entry to the log. They have to authorize that update. And remember, the authorization key should be different from the keys that are used in the DID doc. So there's no requirement that those keys be the same. And in fact, it's encouraged that they not be the same, that you use one key to authorize updating your DID doc, and you use other keys for when you sign, decrypt, use the DID itself. Once you do that, you've published a new entry. Others can resolve that new entry. They have access to it. And you just repeat the cycle. The DID controller can do that as many times as they need to, publish new resources and so on. So where are we with the specification? Currently at V05. We have 5 implementations, 3 are open sourced. Each really providing good feedback into the spec. The information site that I mentioned, this is in the DID methods registry, and it's available at the Universal Resolver. With the V1, we're very close. We've removed the weight from the witnesses threshold algorithm. Again, into the details. We've clarified the DID WebVH. The concept of watchers is being added. We've avoided this because there really is no technical reason why anyone can't stand up a watcher and can use a watcher as a watcher is independent of any DIDs, and we think that watchers should be a sort of generic DID concept rather than a necessarily tied to DID WebVH, and so that's why we've kind of avoided it, but we've agreed at our last meeting that we would allow it. And so a watcher is simply a URL. That URL is somehow agreed to watch a DID WebVH, and they've interacted with the DID controller to say, yep, I'm going to watch it, and here's the URL to use to watch it. There's a watchers entry, likely, as I said, this hasn't fully been spec'd, but likely the technical details are that there's a watchers array listed in the parameters, and it contains a set of URLs, 1 or more URLs, and then each of those URLs must respond to 2 endpoints, either a get of the SCID or a post of the SCID. The get is done by resolvers who say, hey, I'm going to use this watcher to get the DID log, and I'm not going to use the original source. Or I'm going to get it from the original source, and I'm going to get it from a watcher, and I'm going to compare them. Again, those types of uses, those are all outside of the spec. How you want to use a watcher, that's up to you. And so there's no governance around how a watcher works. The post endpoint is to be a webhook from the DID controller that says, hey, I've just updated the DID, so you should grab another copy. And so that is there to prevent the need for the watcher to be constantly polling to find out if the JSON-L file has changed. So the idea is a webhook saying, hey, it changed. I don't know what it changed to, but go the watcher can then know that it has to go get the update. And then the rest of the update is clarifications. We don't see any other changes. This watchers is the big change that's going to go in there in the last version before 1.0. Finalizing the spec, I'm taking way too long. Finalizing the spec and move to standardization, that's the work to be done. There is work going on the thing called DID SCID, and I think it's wherever DICE is this week, they're going to be talking about DID SCID as a DID metadata method. So it's a possibility there could be some alignment with that. DID WebVH server, this is mostly done, but allows for separation of the DID controller from creating, rotating, and using from publishing the DID. And so that's what's there. There is resource hosting. We've got a first example of using it on creds for hosting of resources. And then it's all about implementations and getting real stuff out there. A standalone resolver library, Akapai, Credo, bifold wallets, all with full and on-cred support. That Akapai is mostly done. Credo and bifold are in progress as I speak. Reference witness and reference watchers, assuming we add watchers. And the idea of the watchers, I mentioned, long-lived resolution independent of the DID controller. I did want to talk briefly about an on-creds method. Patrick St. Louis, who was on last week, did a fantastic job at implementing this and building a plugin that now exists in Akapai. And so The background in OnCreds methods is a registry of how you use an OnCreds with a given did method. Defines how you publish JSON objects, a schema, cred-def, a revocation registry, and a revocation registry entry. Historically, those have been published on a ledger. This enables it to be published with a did WebVH, what we're going to talk about here. We did that using a thing called attested resources. And this is a spec in and of itself, but currently it's defined within the did WebVH and OnCreds method spec. So again, linked here. So it gives verifiability to the resources associated with it did. Basically, a resource is a JSON object, so it's stored in an attested resource as an entry called a resource. So if it's an OnCreds schema, this angle bracket resource is replaced with the data structure, the JSON data that is in an OnCreds schema. Same with the cred-def, same with the revreg definition, and so on. Those are embedded in a JSON LD attested resource with metadata and a proof. An identifier for the resource is generated that is a hash of the resource. So that gives an immutability proof. When you get the identifier and it's embedded in a verifiable credential or it's embedded in a verifiable presentation, it has the identifier in it. That identifier has a hash of the resource, and you can make sure that the resource has not been changed since that identifier was generated. And then finally, a proof is added, a data integrity proof is added by the did controller across the entire attested resource object. It gets tricky in the did WebVH with the many revreg entry objects. I'm not going to go into the details there because I want to show a demo. Hopefully this will work. Patrick put this together to show end-to-end use of did WebVH. So I'm going to play this. Hopefully, if I can get a thumbs up, if people can hear the sound, I'm going to put this to full screen once I start it, and you can hear Patrick talk about this.
Hi everyone, welcome to this demonstration about the ongoing work that's happening with
Audio is good.
For this demonstration, we're going to be showcasing full credential exchange in between two identified agents. One as the issuer, a single tenant as issuer, and a multi-tenant instance as the holder. The full flow will include revocation as well. So let's get started. First thing to do, I need to create a sub-wallet on my holder agent. So I'm going to go ahead and register a passkey on my device and bind it to a sub-wallet. There we go. Next, I want to connect this new sub-wallet to my issuing instance. So I'm going to go ahead and scan this did exchange invitation. Wait a few seconds for the connection to be established. There we go. If I refresh my wallet here, I can see new connection is active. Now, the next thing I want to do is send a credential offer. For this demo, the issuance is automatically completed, so no user input is required. Again, if I refresh here, I can see my credential is not in my wallet. I'm going to now request a presentation. Again, should be all automated. And it's verified. Now I'm going to revoke this credential, which will delete the presentation exchange, the previous one. It's now revoked. The green line here represents my status list. So there's currently 100, a size of 100, and we can see the first bit that's been flipped here that corresponds to my credential. I'm going to request another presentation, and then this time it should be unverified. Unverified. Now all of these can be verified with the issuer's admin interface. Open this new tab. So we can, for example, resolve my did for my issuer using the resolver here. You can see my did document with the did WebVH did. We can have a look at the schema, and then you can verify any other OnCreds objects. So these OnCreds objects are published on the did WebVH server Pi, available on the diff GitHub page. There we go. And if we click on these links here, it should open a new page. This is a did WebVH resource resolver. So these are called attested resource. We can see the raw format here, very similar to a verifiable credential. There are three key components on here. We have the content, the metadata, and the links. So if we look at the content, that's the AnonCreds object itself, in this case, as defined by the AnonCreds specification. The metadata is some additional metadata available to the objects, which is going to find what type of object it is. And there's a hash of the content available here. And then we have some links. So in the case of a revocation registry, we're going to publish a link for each of the revocation states. And finally, a proof. So we can see here the size is 100, and I can have a look here at the different states that's been published. So if we have a look at the ones that I just published with the demo, we can see that there's a revoked entry. And if I look at the original state, we can see that, this is my original state, so there's no revocation. So if I was to revoke a batch of, publish a batch of revocation, I would publish a new state and the revoked credential would appear, and then verifiers would be able to tell that it's revoked. So that's where we're at. It's currently working really well. The next step, there's work started to make this work with Credo, so we want to be able to issue this into Credo. And that's pretty much it. Thank you very much.
All right, hopefully that worked well. Everyone could see that. And then the last thing, I'm obviously out of time, but I'll just cover. We are adding the /whois. This is now a separate spec. But the idea of this is that given a did, you can resolve the did/whois endpoint, or did URL, I mean. For did WebVH, that results in a returning a verifiable presentation signed by the did, and that can contain or should contain verifiable credentials about the did or the legal entity behind the did. And that's really powerful. You want a verifiable credential included in the /whois that binds the legal entity identifier with the did. So something like the glyph LEI identifier with the did. So you want somebody, some authority to attest to this did is controlled by this legal entity. Also enables permits, licenses, registrations from the government that are bound to the legal entity identifier. That in turn binds to the did. So now who the did, who controls the did, what permits and licenses they have. They could also have credentials from auditors. They could have membership credentials from trust registries. So a trust registry could have its list of all its pieces, but it could also publish a verifiable credential that the did controller can put into their whois verifiable presentation. And now you don't have to go to the trust registry. You can just verify the signature of the trust registry. Our goal is a separate spec that applies to all did methods. We do have approval to incubate it. We do have a spec that exists. We just need more time to spend on it. This covers how you use whois in the real world, and how you would use it associated with a verifiable credential and an issuer did, but you don't know who it is. And so you use the /whois to find out who it is, find out, given this did, what attestations do they have about the did and whether you can trust it. So that wraps up. At time, and I apologize for taking so long because I didn't leave any space for questions. If there are questions, happy to take them.
This is awesome. Thank you so much. I think we probably all have meetings at the top of the hour to get to. I definitely have questions, but I will ask them at another time. So thank you so much. Join us everyone next week for to hear about OpenID Federation. So thank you so much, Stephen.
Take care all.
Thanks everybody for joining. Thank you.